largest during the sea control. It goes without saying that this small object has been shaping the course of fate ever since ancient times. Now, if I roll the die, we won't be able to guess correctly which particular number will show up, can we? Well, maybe not all the time, but mostly. Well, considering that the numbers ranges from 1 to 6, when strolling in the mall or even in school, we never know the chances of bumping into an old friend or knocking.
Indeed, life is full of surprises. Like what famous Jackson said in the movie Titanic, you don't know what hand you're gonna get dealt next. You'll learn to take life as it comes out. Don't you agree? If not, don't worry, because later on, we will be introducing mathematicians and physicists also do in the question. Join us, to delve in immerse in a universe without place dice.
Or perhaps the dice play God.
Now, we head to chapter 8 of Ian Stewart's book entitled Nature's Numbers. The first name we see is that no other than Sir Isaac Newton. It contains his vision of the clockwork universe. All is set in motion from the beginning, or what is commonly known as the creation, and its movements in an orderly fashion akin to a well-oiled machine. Great mathematical astronomer Pierre Simon de Laplace also shares the same vision through the idea of determinism, a belief that the past completely determines the future.
In 1814, Laplace mentioned in his book a philosophical essay on the probabilities an experiment coined as Laplace demon. Unfortunately, it's not a mythical creature as the name suggests, but rather a thought experiment in determinism that describes a being that knows the present and through it the past and the future. This being knows about everything in the state of the universe at one particular moment. It also has the computational capability to grasp that knowledge, understand, and analyze it. Simply put, Laplace demon is used to represent determinism.
If we were to accept Laplace's take on determinism and completely reject randomness and sheer luck, then it would be the same as saying that we abandon the idea of free will. Instead, we'll operate on the fact that everything that we do is determined, cause and effect. The past causes the present, and the present causes the future.
It was because of this argument that prompted Albert Einstein himself's statement in the letter written to his colleague Max Planck, "You believe in the God who plays dice, and I in complete law and order."
If Newton, Laplace, and Einstein were right all along, why does so much of our daily experiences indicate that they are wrong?
Would you believe that it's been 2 centuries since Laplace proposed this thought experiment? Well, there were those who bought his idea. Others had strong arguments against it. In this chapter, Ian Stewart also challenged the deterministic world concept. Quantum mechanics would be Werner-Ginsburg's direct answer to the question. It presents an indeterministic model of the universe as we know it. An indeterministic world or universe is one where we believe to be governed by libertarianism or free will, chance, and luck. Quantum mechanics says that the subatomic particles don't really obey the rules of classical mechanics. You cannot predict behavior, you can only really cite probabilities.
Let's take a less ambitious example for us to fully grasp how unpredictability can be reconciled with determinism, like drops of water dripping from a tap. In 1978, a group of iconoclastic young graduate students at the University of California at Santa Cruz formed the Dynamical Systems Collective. When they began thinking about this water drop system, they realized that it's not as random as it appears to be. They recorded the dripping noises with a microphone and analyzed the sequence of intervals between each drop and the next. What they found was short-term predictability. If I tell you the timing of 3 successive drops, then you can predict when the next drop will fall. The point being, you can never measure the initial state of a system exactly. There's no such thing as a totally perfect measurement when it comes to this, and this phenomenon is called sensitivity to initial conditions, or in layman's term, the butterfly effect.
Hey guys, I hope everyone finds it easy to catch up with the topics and information introduced by our group. What is the butterfly effect? The butterfly effect, or formerly known as the chaos theory, is a concept that states that small causes can have larger effects. This was initially used in theories about weather prediction, but later the term became a popular metaphor in science writing. In chaos theory, the butterfly is the sensitive dependence on initial condition in which a small change in one state of deterministic nonlinear system can result in large differences in the later state.
For us to be able to understand it more clearly, we'll explain one of the greatest examples of the butterfly effect in history. Take note that these events actually happened in real life. There is but one exception to that rule, which is that she could be by his side publicly while he was acting in his military capacity as the Inspector General of the Austro-Hungarian Army. One day, he and his wife Sophie rode quite foolishly in an open car so that everyone could see them together, and then got assassinated by a Serbian nationalist, Gavrilo Princip, who literally ran up to the open-top car and shot both of them at point-blank range, killing them instantly. To cut the long story short, Austria demanded an apology from Serbia. Serbia refused to apologize, so Austria declared war on their country. In return, Russia, as Serbia's biggest ally, then declared war on Austria. Germany, as Austria's biggest ally, declared war on Russia. France and Great Britain, then as Russia's allies, declared war on Germany. And there you have it, World War I. Talk about a reaction chain.
Oh man, looks like we're running out of time. I guess this concludes our educational vlog for today. We hope we were able to impart with you jam-packed fun and rich knowledge for you guys. Here are a few take-home pointers for you to remember from our discussion today. Number 1. Pioneers such as Sir Isaac Newton and Pierre-Simon de Laplace believed that the mechanics of the universe was understandable and predictable.
Second, however, once experiments required more precision, significant figures became more important. It became harder to produce the same results even if the given starting parameters are nearly identical, but given vastly different outcomes instead.
Lastly, for our final point, whether deterministic or indeterministic, it's up for us to make each day count. We may not be able to control or have full control of the inevitable factors in our life, but let's try to make a difference with the ones that we can. Until next time, thank you.